What's up everybody, welcome to another Python recipe. In today's video we're going to talk about sequences and arithmetic operations on sequences. So here the problem statement is what are the arithmetic operations that are allowed on sequences and how to use them properly. And by arithmetic sequences I'm talking about the plus, the minus, the multiplication, the subtraction and the augmented assignment for each of these. So without further ado, let's get started. For this, let's consider these two sequences. So a string and a list. So we have Bob and 1, 2, 3. Okay, here they are. Let's now try to do a plus. So we can, like you can see here, we can sum two sequences. So s plus s equals 2s. So basically we have now Bob and Bob. So we have summed the first string. Now we can do the same for lists. We can now multiply by an integer. So if we do this, we get 3 Bobs. And if you look at this example, so far so good, which kind of shows us that these, like the plus symbol and the multiplication symbol, as long as you multiply by an integer, are allowed operation in Python. What about the minus symbol? Well, this is not an allowed symbol in Python, operation in Python, same as multiplying a list by a list or dividing a list by another list. These are not applied. These are not allowed operation, be it with string or list or whatever, mutable or immutable. These are not allowed. So now let's consider the augmented assignment. But first let's see what's the bad way to actually extend a list in Python. So you may think, if you want to add, let's say we have this list 1, 2, 3, and if you want to add 4, 5, 6, the most intuitive way, like the natural way to think you can do that, is doing this way. But this is not actually very performant, and we will see why. If you look at this, here you're trying to add these 3 other elements to this list and assign it back to the original list, which means that here, but the problem is that here, this part will create a new Python object in memory and assign it to this original list. As you can see here, this is the proof actually. So our initial list, this was his ID in memory, and after the assignment, when we print back the after we done this expression here, after Python has evaluated this, now indeed we have extended the list, but we have a new object in memory. It's not the same as the one we had before. It's actually a different object in memory, which is not very performant, because here you're not leveraging on the fact that the list is a mutable sequence in Python. And since it's mutable, you can instead do the modification in place, which frees you from having to create a new object first in memory and then assign it to the original one. And Python internally you have to garbage collect the object that was first pointed by this reference, which is a lot of work happening under the hood, and which slows your program by a lot. The best way to do it instead is to use augmented assignment in Python, and this is what this next snippet is about. So this is why we call it the good way. And as you can see here, instead of doing L equal L plus blah blah blah, we do L plus equal blah blah blah. And as you can see, still we have extended our list, but now this time L is the ID of the list is the same in memory. So the modification was done in place, and there's no temporary object created in the memory and no garbage collection happening. Everything happens in place, and believe me, it's much faster, especially when you're doing these kind of things in a loop. It's much faster to do it this way. Likewise, you have the augmented assignment for the multiplication of a list. So let's run this snippet. So here we are trying to augment, to extend this list, but actually just duplicate its content 2 times, or you can do it 3 times if you want. It doesn't matter. But the point is that it would have been a bad idea, similarly as we discussed before, to do it this way. So we prefer to do it this way because here we are doing the modification in place. We are doing it in place. As you can see, these IDs are the same. Now, what about strings? Because so far we have done these augmented assignments on lists, which are mutable sequences in Python. What about immutable sequences? Well, the story is a little bit different for strings. Let's see why. If you remember, for lists, we said this was the right way to do the assignment, the augmented assignment, and to extend the string, to extend the list. This was the right way for list. This was the right way here. But why is it not the right way for string? Well, the problem is strings are immutable. Strings are immutable in Python. So whether you do it this way or you do it this way, it really doesn't matter, because at the end of the day, the real difference, the difference maker in the case of a list was the fact that lists were mutable. So under the hood, the implementation of the plus equal operator in Python is different for lists and strings, and by extension for mutable and immutable types. So that's why for string and all immutable types, plus equal is exactly the same as doing the assignment this way, which is not efficient. And for proof, you can see that the IDs are changed. So the first time we printed the ID of the S, and the second time we printed, these are not the same. And to see this even further, let's consider that we want to concatenate this string here, the Python string. Let's say we want to concatenate this, and we want to do it this way. So the problem is that doing it this way, this is bad actually, to do the concatenation this way, because first Python will have to create a temporary object to concatenate these two, and then once it has a temporary object in memory of the concatenation of these two, it will then concatenate that temporary object here with the C3 to finally create the whole sequence. So imagine doing this 1,000,000 times, 1,000 times. It's a lot of temporary object being created in memory under the hood, and a lot of garbage collection to be done for this temporary object to finally build the final string that you're trying to build. But there must be, and there is, a better way in Python. And the way to do string concatenation in Python in a way that is efficient and very fast is to use the join symbol of the str method. So here you join this way, you put an empty string here, and you join like this. This is how you want to do string concatenation in Python in a way that is efficient without involving temporary object being created under the hood, neither a garbage collection of this object being done under the hood. And the advantage even with the join is that you can concatenate in a way that is that you want. You can add a separator in between. Let's do it this way. You see, we can change it. We can do many things, like you have the flexibility to do it this way, and on top of that, it's very efficient. So yeah, with that, we have reached the end of this recipe. Hopefully you learned something new. If the case, please give it a thumbs up, and feel free to ask any question in the comment section down below. I'll do my best to answer these, and as always, you can find the code for this recipe in the description of the video. And thanks for watching. Be sure to subscribe for our next video, and see you soon.